Here I have a disassembled Lewis LHp brake. I wanted to show you the disassembly, but I unfortunately deleted some videos. It was my mistake, so now I have to show you how to assemble it. It will be still interesting, but maybe the other way around that you are used to. So yeah, quite a few pieces here. I gotta take care not to lose anything. Let me start with caliper. So this is Lewis U4 caliper. It consists of two piston pairs. Both are 17 millimeters. They are the same shape and size as the on Lewis LHt, except these ones are made out of stainless steel, and they also have the ceramic inserts. Compared to the calipers on LH4, they have nothing to hold on to pull them out of the caliper. So I pumped the brake until one fell out, and for the others I would have to pull it by this hatch, or maybe close this hole and put the air in to pop it out. But there's nothing to hold on, because on the others they had a groove on the inside, where this one has this ceramic insulator, where you can grab it with your pliers and pull them out. So I don't know what is the official way to disassemble it, but I see nothing to hold on to. Okay, the pistons are roughly 17 millimeters. Yeah, they are all the same size. And compared to the other older calipers, they have all passages on both sides, so on the front and on the rear of the caliper. Like here is the bleed port, and here is one oil passage to this half, and there's another oil passage connecting both halves together. Here you can see how it's made. Inside you see this groove. This groove is made by a T-slot end mill, so it mills into somewhere here below this surface, and then they drill this hole to connect it together. And both halves, both piston bores, both cylinders are connected with this slot here. And same goes for this connection. Drilling in this direction connects them together. These brakes have this cooling fins. I have to wipe them, which are not removable, so they are shaped the way they got locked into the place. They are not, this one is the right one. So yeah, you cannot remove them from the brake if you do not disassemble the whole caliper. When disassembling this caliper, you have to take care of this small piece. This one is for this part, for the connection amongst both halves. It takes care when you squeeze the O-ring, so it does not block the hole. So when it deforms, it keeps the hole clear of the material. Otherwise, yeah, I will now reassemble it together. So I'll just put this piston back in, push it in. Have to take care of this one, don't lose it. Put new O-rings in, and both cooling fins. I don't know how effective are these cooling fins. Maybe I will have to use the thermal paste, like on the processors of the computer, to ensure better heat transfer amongst the braking pad and the cooling plate, with cooling fins. Yeah, this set of brakes was made in for Chinese market, not for international market, so it's still a little bit rough on the edges. And yeah, I'd have to, maybe they have already changed something regarding the design and production quality. So it's not the latest iteration of this brake, but it should roughly be the same. So yeah, that's it. This is a sample caliper. This is the retaining bolt, which retains the pads inside, but I don't know why it has no head. So you can just screw it through. So it's held in just by the pin, by the safety pin on the other side. So interesting decision, but I see roughly no reason why. Maybe they had no place here for the head. Otherwise I see no good reason why it is this design, because even if I screw it in, will it stop? Yeah, it stopped. There's looks like there's no thread all the way through, so at least this, so at least stops somehow. Otherwise, on the other direction, you cannot really tighten it down, so it's always loose a little bit. Interesting. Okay, the pads are the same as in the LHT. So Lewis TP40 or LP40. This is the same size as Hope V4. And for Lewis pads, TP means sintered metallic pads, and LP means organic resin pads. So you have two types to choose from, but you can buy all compatible brake pads in a lot of shops probably. So they are Hope V4 sized. This spring is quite strong. The role of this spring is to prevent rattle of the pads and these cooling fins. But if it's too strong, it will push the pistons too far in and you will have too much restroke. So if this happens, just squeeze this spring a little bit to make it a little bit weaker, and the feeling of the lever will be much better. Okay. Okay, this is the hose. The connection is the same as on the LHT. So you have this Lewis anti-oil loose system where this olive is removable, but it's mangled a little bit. So you will get a pair of new ones in the shipping, in the packaging. So regarding the connection here, this pin pushes the magnet away, which is in the lever body, so it opens the oil port in the lever. And this olive here is just for sealing amongst the pin and the hose. And the sealing amongst the lever body and the hose is done by this O-ring, which is on the end of the pin. Here's an O-ring. Okay, on the other side, standard, now we can say standard 6mm M6 banjo connection. And yeah, now I see they have their own branded hoses, like Lewis TP T200. Maybe they have grown so much that some supplier makes them especially for them. Maybe I should cut it open to see how it's made. Okay, let's take a look at the hose. We'll cut it here. In any case, I'll have to shorten it, put it on the bike. Cut a little bit off. Set it aside. Okay, hose. Totally standard hose, like, what is that, external diameter 5 probably, yeah, 5 outside to inside 1.7, yeah, so it's normal hose. I'll try to cut through it and try not to cut myself. Okay, let's open it up. So, outer layer, protection layer, some kind of probably Kevlar braid which holds the pressure. The surface of the hose or something. I really can't. Usually you can just pull it out, and here I can't. Oh shit! It's glued together, apparently. So this... Huh. Nice. So this fabric, this Kevlar fabric, is glued or welded, so melted to the surface of the hose, or the internal hose. Interesting. Never seen this before. Wow. Okay, now I can peel it, but see it here how it is melted together. Interesting. Okay, interesting hose. Have never seen such hose before. Okay. Okay, let's continue with the lever. First, I would like to compare lever bodies from before. So this is one of the first LH4 brake lever bodies I got. This one has been crash replaced. And this is the new one. So this is the new one for LHP. What can be immediately seen is these grooves here. These grooves are to make... these grooves are here to help the diaphragm not to tear up if you are replacing it. So the thing is, on the old ones, had this diaphragm, which is the same size as the new one, but all the forces on it were exerted on these two holes. So when the diaphragm is moving, when you are bleeding, or when you are using your brakes, etc., there are some force exerted on these holes, and it may tear. So everything is okay until you disassemble the reservoir. Then it will be really difficult to reassemble it back without any leakage if you have a tear here. So the new diaphragm has these dimples which get stuck into these grooves here, and the force is then transferred onto these dimples. So the holes are not under stress. So this is one kind of a change for the new generation. This one is also present, this change is also present on newer LH4 brakes. So regarding the piston here, I'll just put this one out, on this one. The old pistons were secured inside with a snap ring, so this one have a groove for a snap ring, and the new one has no groove, as they are secured with this grab screw here. This one is really difficult to remove. I had a lot of problems removing it. Now I have had to replace it with a longer one, but this one is too long. I have to take a shorter one. This is M3, so M3 sized. Am I right? yeah, M3. Here you can also see etched number 9.92. I don't know what it is, but probably this is this diameter of the hole. Okay, now yeah, here you can also see it's closed, so the hole for the hose is closed with the magnet inside. But when you install the hose, the magnet will move away and the port will open. It's not totally sealed like on SRAM, but it is good enough. The next thing which has changed is the reservoir cover. This one is the old one, this one is the new one. And you can see the new one is much thicker than the old one. Probably to accommodate different diaphragm shape. This has just one groove, the others had more. They are still bent. If you put it together like this, you can see they're not straight. The reason is if this cover would be totally straight, when you put pressure with these two bolts onto the diaphragm, the pressure would be mostly exerted through this area here, and there will be hardly any pressure in the middle, and you could have a leak here. So they have just bent it a little bit, and now when you secure it with the bolt, it will flatten out and the pressure on the diaphragm will be more or less the same on the whole surface, all around it. Now here I have 3 different pistons. This is from the first gen, this is from the second, and now this is the new one from the LHp, because LHp has a sleeve. So this sleeve is installed into the lever body. It is directional because this hole is not round, you see. You have to take care how to install it. So here the grab screw holds it. There's also a small ridge not to fall out. And yeah, this is this way, like this. These 2 O-rings seal against the lever body, and this O-ring seals against the sleeve. The volume which changes here is not problematic because the port from the reservoir to the cylinder bore is right here. So when it displaces, the oil will flow from the reservoir into this compartment and then back. Okay, compared to the others, the second gen has the same diameter all the way, and the first one also. Now, this backup seal doesn't seal any pressure per se, because all the pressure is made by this cup seal. This is the main seal, which pushes the oil to the hose for braking force, and this one has just to keep the oil from leaking out of the lever body, and that's it. Even it can also carry a little bit of negative pressure, like because when the pads are used and the diaphragm is deformed due to this, there could be a little bit of under pressure in the system. So it can also be said that it seals the air not coming into the brake from this side. So no pressure whatsoever on this seal. Okay, now let's continue with this lever plate. This one has a mechanism which moves its pivot point. So this is a pivot point adjuster made by this worm gear, which is turned, and then the pivot moves around. If I put this one in and spin it, okay, where it is now, you can see how it goes around. It also has a clicker which goes into this hole, so it has a spring and a 2.2 millimeter ball which clicks when it's being turned. So you have to take care when assembling it or disassembling not to lose this small ball and this spring. Take care. On the opposite side, it's retained by this screw and a small washer. So let me assemble it together because I'll need it. Okay, the lever blade assembly is now together. You can hear clicks and this one turns. But the problem is it's not toolless. You see, you have to tighten these two grab screws in order to lock this one in place. Otherwise you have some play in the lever. You can see this movement. This is play. It will work even if you don't tighten these two up, but there will be play. This one will not spin on its own because it's a worm gear mechanism, which in its principle offers transfer of power just from one side to another, not the other way around. So you can't turn this one and expect this one to turn. It won't. The other problem with this is there are no stops. So if you spin this this knob, it will just turn around and around and around, and you can't count the clicks. So to memorize, I have this setting on 5 clicks or maybe on 20 clicks. It's impossible because you don't know where the zero is. There should be some stops to stop it in a certain position and go from there. But it is what it is. It's good enough. Okay. Now let's assemble the lever further. Let's reassemble the lever. So diaphragm, it's more directional, that goes in. This cover, so this is toward the handlebar. It has to be like this, away from the handlebar. And I put the screws in. So this rubber should be seen. This black line should be seen all around the reservoir cover, so you should not pinch it. Okay, assembled. Now let's put the piston in. I have never done it before, so 1.5 hex. This is too small. I mean, it works, but I'm not too happy about it. I should get a shorter bolt. Okay, let's assemble it further. So this push rod goes into the sleeve. Piston goes into the sleeve. And now everything together should go into the body. And you have to take care to have the grab screw where this dimple is. See? Push it in as far as it goes and lock the grab screw. Okay, now I could feel it. That should be it. Okay. It looks it is secure, so it's okay. That's it. Let's put the lever plate on. You can use the contact point adjuster to spin the whole push rod to screw it through the lever body, the lever pivot point. I messed up. It goes like this. Now there are two dust covers, one for each side, which goes over this adjustment mechanism to protect it from dust ingression and water and things like this. I have to pivot it away to be able to get it on. Adjuster. All the way. Now tighten the grab screw. Oh, this one is smaller than one. I have to use something else. Smaller than 1.5. It is then 1 or 1.27 imperial. Inconvenient, at least. This new push rod has grooves like this one, which are made for clicker. So this one also has its own ball, 1.5 millimeter ball, spring, and a small flat screwdriver bolt to keep it in. Another thing to take care when disassembling or servicing this brake: do not lose this ball, this spring, and this really small screw. And that's it.